500 million years ago, the Grand Canyon was not the arid maze of rocks we know today. It was an alien world beneath a warm, shallow ocean. Strange, otherworldly creatures thrived here, unlike anything alive today. Among them lurked a terrifying predator with a bizarre feeding organ, a throat lined with rings of sharp teeth that could shoot outward like a living trap. Today, scientists have unearthed its fossilized remains in a stunning discovery that rewrites our understanding of ancient life. This is not just a worm, it's a relic from a time when evolution experimented wildly. Get ready to journey back 500 million years to meet the Cambrian's most mysterious predator. Chapter 1. Beneath the Cambrian Seas. Billion years ago, where the Grand Canyon stands today, a vast, warm sea stretched as far as the eye could see. Sunlight pierced through crystal-clear waters, illuminating strange, alien-like creatures swimming in endless variety. It was the Cambrian period, a time when life exploded into complexity, giving rise to bizarre predators and resilient survivors. These seas were not just teeming with simple microbes, they were packed with diverse forms, many now long extinct. Giant trilobites crawled along sandy floors, early mollusks grazed on algae, and predators waited in ambush for unsuspecting prey. The world was alive with evolutionary experimentation. But in this alien ocean, there was one creature that stood apart, small, unassuming, yet deadly. A soft-bodied worm that developed one of the most extraordinary feeding mechanisms nature has ever seen. Imagine a worm barely a few inches long, but capable of turning itself inside out to reveal a mouth ringed with sharp, terrifying teeth to its prey. This was a nightmare. To scientists today, it's a priceless clue into evolution's deepest secrets, and the fact that we've found it in the Grand Canyon changes everything. This worm was not just another Cambrian oddity. It was part of a thriving ecosystem, proving that ancient seas here were far richer than anyone imagined. Until now, soft-bodied fossils were thought rare in this region. But this new find suggests an ancient paradise where predators and prey lived in fragile balance. What happened here 500 million years ago may hold the key to understanding how life exploded into forms so varied, so complex, and so strange. Chapter 2. The Grand Canyon's Secret Past. Today, the Grand Canyon seems lifeless, a desert carved by time and water. But hidden in its bright angel shale lies a forgotten world, locked away in ancient stone. When researchers descend into its deep layers, they are not just traveling downward through rock, they are stepping back through hundreds of millions of years of Earth's history. Here, in this stunning geological archive, tiny fossils preserve stories evolution almost erased. These layers reveal secrets no desert breeze could whisper. Back then, the area was submerged under shallow seas, perfect for preserving delicate creatures. Oxygen levels were high, nutrients were plentiful, and sunlight fed vast blooms of algae and plankton. These microscopic organisms formed the foundation for an intricate food web of predators and prey. Every inch of seabed was alive with competition, survival, and transformation. Unlike the famous Burgess Shale in Canada, where fossilization happened during catastrophic events, the Bright Angel deposits hint at something different. Life here thrived in calm, fertile waters, and soft-bodied organisms could be preserved without violent upheaval. That's what makes the recent discovery of the Cambrian penis worm's fossil so extraordinary. It suggests this was not just a marginal ecosystem. but a bustling evolutionary playground. Chapter 3: The Discovery Expedition. In the summer of 2023, a small team of paleontologists embarked on an ambitious journey through the Grand Canyon. Their mission was not just to collect rocks, it was to uncover ancient secrets buried deep within its untouched shale formations. Armed with rafts, ropes, and climbing gear, they followed the path of the Colorado River, venturing into areas few had dared explore. Leading the charge was Cambridge doctoral student Giovanni Massini, whose fascination with early life bordered on obsession. Days of intense rafting, hiking, and climbing brought them to the bright Angel Formation, a treasure trove of Cambrian deposits untouched for millions of years. Here, each sample represented not just sediment, but time itself, holding traces of life from Earth's earliest complex ecosystems. The team carefully pried fragile slabs of shale from the canyon walls, packing them with precision. What they did not yet know was that within these gray-green stones lay one of the most stunning fossil finds in recent history. Back at their lab, they would soon dissolve these rocks, layer by layer, until one extraordinary creature emerged, tiny predator with a terrifying secret. Chapter 4: Dissolving Stone, Revealing Life. Once back in Cambridge, Massini and his team began a painstaking process to uncover their hidden fossils. The shale samples were submerged in acid baths designed to dissolve rock without harming the delicate remains within. It was a slow, meticulous job, requiring weeks of work and endless patience. As layer after layer of sediment fizzed away, fragments of ancient shells, algae, and microfossils began to appear under the microscope. Among these thousands of pieces, something unusual stood out: a tiny, tube-like structure, almost alien in appearance. Its shape suggested a soft-bodied organism, something far rarer than expected from these rocks. Reconstructed an ancient predator, revealing fine rings of teeth and soft tissues preserved in exquisite detail. This was not just a fossil, it was a frozen moment in time, capturing one of Earth's earliest predators in mid-evolution. For paleontologists, it was like opening a window into a half-billion-year-old ocean. Chapter 5: Meet Kraytdraco Spectatus. The newfound creature was unlike anything seen before, though scientists quickly recognized it as a member of the Priapulid family, colloquially known as penis worms. Yet this was not just any Priapulid, it was a completely new species, later named Kraytdraco Spectatus. Its name, inspired by the dragon-like crate creatures of the Mandalorian, reflects its otherworldly anatomy. Measuring around 6 to 8 inches in length, Kraytdraco possessed a body perfectly adapted for its Cambrian world. Its most distinctive feature: a protrusible pharynx feeding tube lined with 2 sets of teeth. The first set was sharp and serrated, designed to grip prey, while the second consisted of delicate, feathery bristles used for filtering nutrients. This dual feeding strategy was a masterpiece of evolution, allowing the worm to both hunt and scavenge with equal efficiency. In an environment where survival depended on adaptability, Kraytdraco was a formidable predator. For millions of years, it thrived beneath the waves, a silent assassin of the Cambrian seas. Chapter 6: The Predator's Hidden Weapon. Kraytdraco Spectatus' most fearsome weapon wasn't its size or strength, it was its bizarre throat. Unlike modern predators, this worm could literally turn part of its body inside out to capture prey. When hunting, it extended a long, tubular pharynx lined with rings of sharp teeth, functioning like a living grappling hook. The teeth clamped down with precision, dragging helpless creatures into its waiting maw. But what truly fascinated scientists was the dual nature of its throat. Behind the sharp teeth was a secondary row of fine, comb-like bristles designed to filter food particles from sediment. This suggested that Kraytdraco was both a hunter and a scavenger, capable of switching feeding strategies based on its environment. Few modern creatures have evolved anything so complex. For researchers, this was more than a strange fossil. It was a glimpse into how early evolution experimented wildly with survival strategies. Nature, still testing the boundaries of possibility, created predators like this that blurred the line between filter feeders and active hunters. It's a reminder that the Cambrian seas were an evolutionary battlefield where adaptability meant dominance. Chapter 7: A Cambrian Explosion of Life. The discovery of Kraytdraco comes from one of the most critical periods in Earth's history, the Cambrian explosion. Roughly 541 million years ago, life on Earth underwent its most rapid diversification ever, producing forms so strange they seem almost alien today. In just a geological blink, ecosystems went from simple microbes to complex networks of predators and prey. The Cambrian seas were filled with creatures sporting bizarre adaptations. Trilobites developed armored shells for defense. Early arthropods evolved compound eyes, giving them a predator's edge. Worms like Kraytdraco experimented with retractable feeding tubes and multi-layered teeth. Evolution, at this point, had no roadmap. Nature was improvising, testing every design imaginable. The Grand Canyon's shale deposits give us an unparalleled snapshot of this chaotic creativity. Preserved here are the ancestors of countless species that would eventually dominate the Earth, from insects and crustaceans to vertebrates like us. Each fossil adds a piece to the puzzle of how complex ecosystems first formed, and Kraytdraco Spectatus provides a particularly striking chapter in that story. Chapter 8: The Fossilization Miracle. Soft-bodied creatures, like Kraytdraco, rarely leave fossils behind. Without hard shells or bones, their remains usually decay long before sediment can entomb them. That's why the discovery in the Grand Canyon is so extraordinary. Something about the ancient, bright angel shale created perfect conditions for preserving delicate details over 500 million years. Scientists believe these Cambrian seas had unique chemical balances that slowed decay and promoted fossilization. Fine sediment buried creatures quickly, cutting off oxygen and halting decomposition. Over millions of years, minerals replaced soft tissues, creating three-dimensional imprints that capture even microscopic features. Thanks to these rare conditions, we can now study the rings of teeth and fine bristles of Kraytdraco Spectatus in astonishing detail. It's a gift from deep time, allowing scientists to reconstruct not just the creature's anatomy, but also its role in an ancient ecosystem. Without these fossils, entire chapters of evolutionary history would remain unread. Chapter 9: Life and Death in the Cambrian Seas. The Grand Canyon's Cambrian ecosystem was a stage of constant drama. Predators stalked prey in an eternal dance of survival, where every adaptation sparked a new countermeasure. Creatures evolved shells, spines, and speed, while hunters evolved sharper claws, stronger jaws, and more cunning feeding strategies. Kraytdraco Spectatus thrived in this world by being versatile. It did not rely solely on hunting. When prey was scarce, it could filter nutrients directly from sediment. This flexibility likely gave it a significant advantage over competitors, helping it dominate ecological niches others couldn't. But even the mighty were not safe. Larger predators roamed these seas, including early arthropods like Anomalocaris, a creature armed with serrated limbs and an insatiable appetite. To survive, Kraytdraco needed more than sharp teeth, it needed strategy. These ancient battles shaped evolution itself, driving creatures to innovate or perish in a constantly shifting food web. Chapter 10. The Mandalorian Connection. When scientists finally described the new species, they gave it a name that captured both its strangeness and its science fiction appeal. Kraytdraco, Spectatus. The name was inspired by the fearsome krayt dragon from The Mandalorian, a nod to the worm's alien-like throat lined with rings of teeth. This playful naming highlights how paleontology often blurs the line between science and imagination. Just like fictional beasts, Cambrian predators, like Kraytdraco, are so bizarre they defy our expectations of what life can be. For modern audiences, comparisons to pop culture make these discoveries more relatable. Bridging 500 million years of evolutionary history, the Mandalorian reference also sparks curiosity beyond the scientific community. Suddenly, a penis worm fossil from the Grand Canyon becomes part of a broader conversation about life's creativity, connecting ancient oceans to the stories we tell today. Evolution's real designs are often stranger than anything dreamed up in Hollywood. Chapter 11. Tiny Titans of the Cambrian. Though Kraytdraco Spectatus was small, measuring only 6 to 8 inches, size didn't determine power in the Cambrian seas. Some of the most successful creatures were tiny predators, perfectly adapted to exploit niches overlooked by larger hunters. Unlike massive arthropods or early vertebrates, Kraytdraco's success came from its efficiency. Its dual feeding system allowed it to hunt smaller organisms while still thriving when prey was scarce. This adaptability made it one of the Cambrian Ocean's stealthiest survivors, operating beneath the radar of larger predators. Today's modern Priapulid worms, descendants of creatures like Kraytdraco, are much smaller, barely a few millimeters in size. Yet their evolutionary lineage connects them directly to one of Earth's earliest success stories, proving that sometimes the smallest survivors leave the biggest evolutionary footprints. Chapter 12. Rewriting the Grand Canyon's history. Before this discovery, scientists believed the Grand Canyon's Cambrian deposits held only limited evidence of soft-bodied life. Most assumed ecosystems here were relatively simple compared to sites like the Burgess Shale in Canada. The Kraytdraco fossil changes that narrative entirely. Now, we know that the Bright Angel Formation hosted thriving, complex ecosystems filled with predators, scavengers, and filter feeders. This was not an evolutionary backwater. It was a hotspot of innovation, where life experimented with bold new forms. The Grand Canyon was not just carved by rivers, it was sculpted by deep time and ancient biology. Each fossil found here adds a critical piece to Earth's evolutionary puzzle. By studying them, scientists are rewriting the story of life's origins, revealing connections between ancient seas and modern ecosystems that we're only beginning to understand. Chapter 13. The Cambrian Puzzle. The Cambrian explosion remains one of science's greatest mysteries. Why did life diversify so rapidly during this period? And why did so many of these bizarre creatures eventually vanish? Fossils like Kraytdraco Spectatus help us piece together the answers. Some researchers believe rising oxygen levels allowed organisms to grow larger and develop more complex body plans. Others suggest ecological competition drove rapid innovation, forcing species to adapt quickly or die out. Whatever the cause, the result was a period of unprecedented experimentation in form and function. By comparing fossils from different Cambrian sites around the world, scientists can reconstruct ancient food webs and evolutionary pressures. The Grand Canyon discovery provides a missing link, showing that these experiments weren't confined to isolated hotspots. They were happening on a global scale. Chapter 14. Lessons from a 500 million years. Studying Kraytdraco Spectatus is not just about understanding the past. It's about seeing our place in evolution's grand narrative. The strategies this tiny worm evolved, adaptability, versatility, and efficiency, are the same traits that drive life's success today. Modern ecosystems, too, face constant change, forcing species to innovate or perish. The Cambrian seas remind us that adaptability is nature's most powerful weapon, and survival often belongs not to the strongest, but to the most flexible. By unlocking the secrets of ancient life, we gain insights into Earth's future. Climate shifts, extinction events, and evolutionary pressures still shape the biosphere, just as they did 500 million years ago. The story of Kraytdraco is, in many ways, our story too. Chapter 15 Outro. Echoes of the ancient seas standing at the rim of the Grand Canyon today. It's hard to imagine the alien world that once lay beneath these rocks, but fossils like Kraytdraco Spectatus remind us that deep time is never truly lost. It's written into the stones beneath our feet. 500 million years ago, strange predators swam through shallow seas where desert winds now blow. Today, we can study them, understand them, and marvel at the evolutionary pathways that led to life as we know it. It's a humbling reminder of how fragile and extraordinary our world truly is. If you enjoyed this journey through ancient oceans, do not forget to like this video, subscribe to the channel, and hit the bell icon to stay updated on paleontology's latest discoveries. The Cambrian seas still hold countless secrets, and together we'll uncover them one fossil at a time.